All right, going on in section 6.4, we're going to talk about factoring completely. And we're going to need this skill in order to solve the polynomials that we're going to encounter here coming up in a couple sections or so. But the topic today is factoring completely. And to teach you what that word means, we're going to go back to what you learned in the prior video lesson about the remainder theorem, because this is going to be our technique we're going to have to use. Again, we're going to do synthetic division, and first thing we're going to have to determine is the given factor's remainder 0. And then from there, we're going to have to totally break apart the polynomial, which is what factoring completely means. Now, in order to do that, we're going to do some examples. Number 1, is x minus 7 a factor of the polynomial x to the third minus 8x squared plus 5x plus 14? And if so, factor completely. So there's two parts to this. The first part is like you just did in the prior video lesson. You got to determine, is x minus 7 a factor of this polynomial? And then if it is, then we got to do the factor completely part. Well, I'm going to write over here on the left side. I'm going to write the word factors because that's where we're going to list our answers. Now, first thing, I inspect the polynomial. Is there a like term or anything that I can pull out? And the answer is no. So therefore, my a value is 7. So I'm going to put 7 in the little box. And then my coefficients are 1, negative 8, 5, and 14. So let's do synthetic substitution or synthetic division and see if my remainder is 0. I bring down the 1. 7 times 1 is 7. I add the 2. I get negative 1. 7 times negative 1 is negative 7. I add the 2. I get negative 2. And 7 times negative 2 is negative 14. Aha! My last number is 0. That's my remainder. So the answer is yes. Yes, x minus 7 is a factor of this polynomial. So I'm going to list it over here. X minus 7 is one of its factors. So then I can do part 2, factor completely. Now how do you do that? Well, you take the remaining coefficients and you write them down as a polynomial. Now remember, we go down 1 power. It was x to the third, so now that 1 is 1x squared, minus this one is 1x, and that would be minus 2. Can I factor that? Well, it's a squared polynomial. This goes back to Unit 5. Can you throw in your 2 sets of parentheses and factor it? And upon close inspection, you're going to see yes, because x and x goes here. This minus means my signs are opposite. Things that multiply together give me 2 is 2 and 1. If I check my rainbow, there's positive 1x, negative 2x, and I get my middle. So therefore, here's my other factors. My other factors of this polynomial are x plus 1 and x minus 2. Now, how do I know I'm done? I'm done because the powers of x are 1. I cannot factor or simplify any further. Also, it's x to the third, which means there's probably 3 factors. 1, 2, 3, and that's it. Now, if I would times these 3 factors together, I would get this polynomial that's in the red box. If I multiplied them, I would get this. So I'm done. I have factored completely, and that's what factoring completely means. Let's try another one. Is x minus 1 a factor of x to the fourth plus 3x to the third minus 4x? And then if so, factor completely. Well, the first thing I'm going to notice about my polynomial is there's an x in every term. So I can actually factor out an x. Well, if I pull out an x, what's left? It'd be x to the third plus 3x squared minus 4. So on the side, again, I'm going to list all my factors. And my first factor is an x. Now, I don't need that x anymore. I'm done. I just need what I'm underlining because I'm continually breaking it down until my powers of x are 1s. So now I can do synthetic substitution or synthetic division. My a value is going to be 1. And then I write down my coefficients. 1, 3. Now the x term is missing, so that's 0. And then negative 4. So now, if I work this out, I bring down the 1. 1 times 1 is 1. Add the 2, I get 4. 1 times 4 is 4. I add them, I get 4, and then 1 times 4 is 4 again, and look at that. My remainder again is 0. Okay, good. So that means, yes, x minus 1 is also a factor. So I'm going to write that over here. X minus 1 is also a factor of the polynomial in the blue circle. Well, I got to keep going because I still have a polynomial left, actually a quadratic in the red box. That is x squared plus 4x plus 4. Again, upon close inspection from your lessons on quadratic equations, this is x and x, and the plus signs mean that these signs are the same, and obviously it's going to be 2 and 2 because my insides become positive 2x and my outsides are positive 2x, which makes my middle. And here are my final two factors. I've got 2x plus 2's. Now again, my highest power is 4, so I should have 4 factors. The number of factors should match. And there you go. And I have now factored completely. The last one. Is x plus 2 a factor of x cubed minus 8? And if so, factor completely. All right, well, let's take a look at this one. My a value, x minus negative 2. My a value is negative 2, so that goes in the box. My coefficients are 1, the x squared term is missing, the x term is missing, and then the minus 8. So let's see, is this a factor? Bring the 1 down. Negative 2 times 1 is negative 2. Add them and go through this process again. Add 0 and 4, get 4. And negative 2 times 4 is negative 8. Uh-oh. Uh-oh. My remainder is negative 16. So is x plus 2 a factor of this? The answer is no. Well, I'm done. We're stuck as of right now. So therefore, I can go no further. This problem is done. And I hope that answers what factoring completely means. If you have further questions, please ask during class.